All right, in this section, we're multiplying radicals together. So basic rule, if these are the same index, all you have to do is multiply the radicands together, as long as both the A is positive and the B is positive. Or equal to 0. Okay, so that's a positive 6, that's a positive 2. I put those together and then simplify. Smallest square, or largest square that divides in 12 is 4. 2 root 3. Both positive. I don't know what 14 times 8 is. So that is root 112. Let's see. And now I'm figuring out the largest square that divides evenly into 112. All right, so far I'm down to 25, which doesn't go in. 16. And the square root of 16 is 4. As long as it's multiplication, it doesn't really matter what's on the outside or inside, as long as they're the same index. All right, so here I have a 3 multiplied by 9. It's going to give me negative 15. I also have 12 and the 5 on the inside. 12 times 5 is 60. And the smallest prime in the 60 is 4. Square root of 4 is 2. There, so we can root 15. All right, so the negative on the outside, that's like a negative 1. And then we have the 7. And the 18 and the 20. So the smallest prime that goes in evenly, or the smallest square that goes evenly into 360 is 36. Is 6. So altogether, negative 42 radical 10. All right, just to recall, square roots of an exponent. You divide the exponent by the index. So if I want the square root of 6 of x to the 6, I'm going to divide the exponent of 6 by the index 2. So it gives me 3. Square root of x is x cubed. Okay, but what if it doesn't go in evenly? Okay, so square root of x to the 7. I'm still going to divide the exponent by the index. 2 goes into 7 3 times. Then I want you to consider as remainder. How many do you have left over after you take out the 3 of the x squared? You have 1. This is really x squared. That's a lie. X cubed, x to the 1. That's where your x to the 7 comes in. So this is really x root x. Okay, so 9, divide the exponent by the index. 2 goes into 9 4 times. So that's x to the 4. But it has a remainder of 1. So inside your root, you have an x to the 1. Okay, as long as your radicands are positive, go ahead and multiply them together, including the x. 20x. Large square that goes into 20 is 4. Okay, remember that's an x to the 1. So right away, can I divide 1 by 2? So 0 with remainder of 1. So what's the square root of 4? Then both a 5 and the x are going to stay underneath. So let's multiply the outsides together on this one. That's 10y. Together, so 18y squared. Largest square that goes into 18 is 9. Square root. Two is going to stay. Now I'm looking at that y squared. Exponent by index, whole number. So square root of y squared is y. So ultimately we have 30 y squared root 2. All right, multiply the the outsides together. And then multiply your insides. Largest square into 50 is 25. Square root of 25 is 5. And then your square root of x squared, exponent divided by index, no remainder, so x to the 1. So we get 40 x squared root 2. Multiply the outsides. Multiply the insides. Largest square at the end of 45 is 9. Is 3. Exponent 3 divided by index 2. That's 1, but this one has a remainder of 1. So I'm going to take an x and the 1 out. Z the 1 out, and we're going to keep a z on the end. So we still have the 5 and still have the extra z.